Variables are containers for storing data values. Python has no command for declaring variables. A variable is created the moment we assign a value to it. For example, we can create a variable, call it x, and assign a value to it 5 using the equal sign. We can also create another variable, let's call it y, and assign it a string text, John. Then we can print these variables using the print function. Inside the parentheses, we can specify the variable name. For example, if I want to print the x variable's value, I simply specify x. After this, we can click on Run, and we get 5 as the output. We can do the same thing for John by simply replacing x with y, run the program again, and now we get John. Now, in the case of the variable y, we assigned it a text value of John. Now this one is a single line string. We can have a multi-line string in Python by doing the following. For example, I'm going to create a variable, call it a, and set it to a multi-line string by specifying 3 double quotes. And here I can type something like lorem ipsum dollar sit amit, and then I can hit enter and continue writing another line. This is another line, and hit enter again, and this is another line, and so forth. Once I'm done writing the multi-line string, then I can close it or end it by the 3 double quotes. Now we can print the multi-line string using the print function. Print a, run the program, and there we go. We get the multi-line string as the output. We can also do the same thing. Instead of using the double triple quotes, we can use the single quotes. So triple single quotes, but then we also have to end it with triple single quotes. Run the program, and it works similarly. In Python, just like in other languages, we can concatenate 2 strings together. Concatenation means combining. To combine or concatenate strings in Python, we can use the plus operator, the same one that would be used for addition between numbers. For example, if we have a variable a and it's set to the string hello, and we have another variable b and it's set to the string world, we can create another variable c and assign it to the concatenation of the 2 strings a and b, so a plus b, and then after that we can print c. Run the program, and we get hello world. Now notice there's no spacing between hello world. So what we can do is we can actually insert after the first plus symbol here, we can say double quotes, space, and use another plus operator to concatenate the B string. And now when we run the program, we get hello space world. The reason this works is because technically speaking, this spacing here is also considered a string in Python. Using concatenation like this can allow you to format your output nicely. In programming, we have an important concept known as data types. Python has the following built-in data types. We have a text type, strings like we've seen so far. We have numeric types like ints, floats, and complex to represent numbers. We have sequence types, lists, tuples, and ranges. We have mapping types like dictionaries. We have set types, we have Boolean types, we have binary types, and we have none types. Most of these data types will be covered later. In Python, the data type is set when a value is assigned. Variables do not need to be declared with a specific type and can even change type after being set. For example, if I declare a variable x and I set it to the value of 4, here x is of type int, meaning a number, because 4 is a number. But since we can change the type after the variable has been set. For example, I can say x equals string Sally. Now, x is now of type string. So when I print x and run the program, now we get Sally instead of the 4. This is because x changed from int to string. It might be helpful in certain cases to determine the type of the variable. We can do this using the type function in Python. So here in the print function, inside the parentheses, we can specify type and wrap the x variable within the type parentheses. Now notice the type became red, which means it was recognized as a reserved function. So we run the program, and now you will see that we get in the output that this variable was determined to be of type string. Previously, I've mentioned that Python is a dynamically typed language. This is exactly what we see here. Notice that I did not have to specify x as either an int or a string. I simply declared the variable and set it to the value, and even changed it later. If we want to specify the data type of a variable explicitly, we can do this with what we call casting in programming. For example, if I have the variable x, I can set it to str3, and as you notice right here, str is red, which means it was recognized as a reserved data type in Python. This is the casting step. So Python will interpret this as follows. I'm going to write it as a comment. So x will be 3 string. Of course, we can also have explicit casting of word strings. For example, if I have a variable like xx and I set it to string, s1. So I'm going to write a comment that this is how Python will interpret it as. Xx will be string s1. Now let's explore another data type. For example, suppose I have variable y. I can set it to an explicit integer number by using int, and I can say int3. So then the Python interpreter will determine it to be a number. So y will be 3. No single quote, so it's not a string. Now, what if I have another variable, yy, and I set it to int, and the number is, let's say, a decimal, like 2.8. Python will interpret this as yy will be 2. The reason why it rounds it down to a whole number of 2 is because integer is a whole number. If we want to represent a number fully as a decimal, we need to use the float data type. For example, we can say z equals float 4.2, and then Python will determine z as exactly 4.2. Now, what if you set a variable as a float, but it's just a whole number? So for example, if we have zz equals to float 3, then Python will interpret this as a decimal. So zz will be 3.0. Now we have seen previously that we can combine strings or text and numbers by separating them with commas in the print statement. For example, if I have price equals to 59 and I have text equals to the price is, then I can print and combine the number and the text as follows. Print text, comma, price. Run the program, and we get the price is 59. Now, what if I want to say, the price is $59? So then what I could do is I can say after the price, comma, dollars. Run the program, and we get exactly that. But is there a different way to format the output? How can we include the price in the text and then just print the text? To do that, we can use something called format strings or f strings and placeholders in Python. Placeholders allow us to embed variables, operations, or functions into strings. For example, in the text right here, I can use a placeholder after the is word by specifying curly braces and then including the price variable name And then after that, I can continue the statement like dollars. And then at the beginning of the string, right before the opening double quotes, I can specify an F. This is the format string. Now notice the placeholder inside with the curly braces in the price has turned into a different color than the rest of the text. This is because Python has recognized this as a placeholder variable inside the text. Now I can simply do print text, run the program, and we get a similar behavior. The price is $59. This makes things much easier simply by specifying the F string and a placeholder that holds the variable inside the text. The placeholder here can actually have something called a modifier. So we can use the modifiers to format the value. To do this, for example, after the price, we specify the colon. And then here, if we want to display the price number with 2 decimal points, we can simply say dot to F. Now, when we run the program, you'll notice that 59 is now specified with 2 decimal values, thanks to this modifier here. We can also include operations directly inside placeholders. So for example, I can get rid of this here, and then I can say something like 20 times 59, run the program, and we get the price is $1,180. Or I can even say 20 times price, run the program, and we get the same result. In Python, indentation is required and defines blocks of code. Indentation refers to spaces at the beginning of a code line. Although we will be covering them later, we will be showcasing indentation through an example of conditional statements, such as an if statement. So for example, if we have if 5 is greater than 2, and this is how you write an if statement in Python, ending it with a colon. Now, typically, the way conditional statements work is if the condition is true, for example, in this case, 5 is greater than 2, so it is true, then we would do something. We can do something as simple as just printing a statement like print 5 is greater than 2. Now, if we run the program, we get an indentation error, expected intended block of code after if statement. So what we have to do is we have to indent the print statement as part of the if conditional statement. We can use a tab for that. Run the program again, and now it works fine. The number of spaces is really up to the programmer, but it must be consistent. 4 spaces is usually the most common standard, or you can just use tab as your indentation mechanism. Let's discuss user input in Python. Python allows programs to accept user input using the input function. Now, normally, you would write a program like this, print, and let's suppose that we are prompting the user to enter their name. Enter your name. Following the prompt statement, we would set a variable to the input. So for example, in this case, we are asking for the name, so we can create a variable name and then set it to input. Notice it was recognized by Python. And then after we take in the input from the user, in this case their name, we would print it back out. For example, print, and here I'm gonna use a format string because we need to embed the name variable within the text. So F, double quotes, hello, and we can use the placeholder and insert the name variable in it. So now when we run the program, notice that the interactive console is blinking. This means that it's waiting for us, the user, to enter something. This something is the name. So here we can enter a string, like my name, Hattie. And then once we hit enter, then line 3 kicks in and gets executed. In this case, it says hello, and then it interpolates the name variable in the placeholder, and it recognizes the input as Hattie. So then it says hello, Hattie. By the way, if you look at line 1, we kind of included an output statement first before we accepted input from the user for their name. So we said print enter your name. We can actually remove this and include the prompt statement directly in the input function. So inside the input function here, we can say enter your name, run the program, and notice that it blinks asking for us to enter something as the user. So I'm going to enter my name again, and we get the same output, hello Hattie. So this is another way to prompt the user. Now, in both of these input examples so far, we have been including the prompt statement, in other words, something like enter your name, a text. Although this is a great way to inform the user what the program is expecting for input, like when they run the program, it would tell them what is being expected and why is it blinking. Keep in mind that for the OnlineGDB platform, automated test case feedback, prompt statements like this should not be included at least before submitting the program or solution. So what you should do before testing the program against the automated test case inputs and submitting the program is you should remove these prompt statements from the input. For example, like this. Now when we run the program, notice that the interactive console is simply just blinking. There is no statement asking us what to expect to enter. Now, of course, in this case, because we have written the program, we know that what's expected is a name. So if I write Hattie, I get the same output, hello Hattie. Although it's a good idea for the users to know what is being expected, OnlineGDB is a machine, therefore you should exclude such prompt statements like enter your name and so forth. If you do not exclude them, then the test cases will not match the expected output and they will not pass, even if your output might be logically correct. Now keep this in mind simply for the OnlineGDB assignments, but if you are creating Python programs for users in the future, most definitely include prompt statement because those users will not have written the program, so they would not know why the program might be blinking or expecting. But just for the sake of the OnlineGDB assignments, since OnlineGDB is a machine, make sure to omit such prompt statements before testing and submitting the program. So in other words, simply keep the input with no text inside it. Now, having said that, in Python, we can actually request multiple inputs. Python will stop execution at each input and wait for the user. For example, if I have a name variable, and again, we are expecting to input the name, enter your name, I can have another variable and also expect input from the user. For example, let's say fav1 equals to input, what is your favorite animal? And we can have another variable like fav2, and again input, prompt statement, what is your favorite color? And on and on and on. Now we can print the input that the user will provide, again by using format strings. So f, double quotes, do you want a, and we can use placeholders to represent the input variables. So for example, I can say specific color of animal. In this case, it would be the fav2 variable, followed by the animal name, fav1. And then we can end it with the user's name that they would have entered. So again, we need the placeholder and we embed the name variable. Now, when we run the program, it says enter your name. So here we can say, let's say Johnny. And it says, what is your favorite animal? So let's say cat. What is your favorite color? Let's say brown. So now what happens is Python interprets all of these inputs as part of the output. And then it says, do you want a brown cat, which is coming from fav2 input variable, followed by the fav1 input variable. So brown cat, and then followed by the name of the person. Now, so far in this example, we have been dealing with text or string-based input and output. Python by default takes an input as a string. But what happens if we want to have a mathematical operation? For example, what if we want to allow the user to enter some number and we output the square root of that number? Well, in this kind of example, first of all, we would need to find out how we can take the square root of that number. We can use a module in Python for that, which is basically like a code library. We can find such libraries through a simple search online. Now, in my case, since I want to do a square root on the number, I found the math module in Python. This module provides access to common mathematical functions and constants. If we scroll down, we find that there's the square root function. And we can click on the square root function to read about it and see how we can use it. So the square root function takes in a parameter and then it returns the square root of that parameter or argument. So let's use this math library and the square root function from the math library or module. To do so, the first thing I need to do is we need to import math, and then after that we need to create a variable to allow the user to input a number. Enter a number. Now we need to find the square root of that number. To do so, we need to create another variable like y, and then we can use the square root function from the math module. So math.sqrt, and according to the documentation of the square root function, it takes in a parameter. So in this case, our parameter is x, which is the number that the user will be inputting or entering. Now, I didn't really call it x because the documentation calls it x here. X here is just a placeholder. I simply called it x here simply for ease of use, but nothing else. We could call it number or anything that we want. It doesn't really matter. Now, after we perform the square root operation on the number, we can print out the square root. So print y, and we run the program. Enter a number, so let's say 16. Oh, we got a type error. So here it says must be real number, not string. This is because Python, by default, accepts the input as a string. So we need to actually convert or cast the x, in this case, into a number. So we can use float and surround the x here. So this is inside the square root function. So we are casting x to a float number. Now rerun the program, enter 16, and now we get 4.0 as the output, which is correct. The square root of 16 is 4 because 4 squared is 16. Now in the output, we can actually refine it a little bit better. So we can use fstring for that. We can say f double quote the square root of x is y, and then end the double quotes. Run the program, enter 16, and we get a better output this time, like the square root of 16 is 4.0. Now, by the way, notice here next to the input that there's not really much spacing after the colon. So we could easily put some space here after the colon, rerun it again, and now it's a little bit nicer. It's a little bit neater. So we can enter 16 and we get the same result again. Okay, just a matter of formatting preference. But remember, for OnlineGDB assignments and submissions, please avoid prompt statements like this one. So when you are testing and submitting the assignment, you would want to remove such a prompt statement and simply keep it to input. Run the program, and in this case, the interactive console would be blinking, and then we can enter 16, and we'd get the same output. So the reason we need to avoid the prompt statement is because OnlineGDB is a machine, and it's not a human like us to understand statements like enter a number. Now, in this example, if we did not cast the x to a float and ran the program, we noticed that we got a type error. It's a good practice to validate user input. To do so, we can use a loop, specifically a while loop, to repeatedly ask for input until valid input is provided. Although we will be covering loops much more in depth later on, so the cleanest and most robust approach to implement the validation is to use the try and except along with the while loop. To do so, we can specify a while keyword here before the input and true, Now we need to indent the X input, and then after this, we need to say try, and then again we need to indent within the try, because this block is going to be within the try, which is within the while, and then we can say something like num equals to float x. So here we are attempting conversion or casting. After that, we say if num is less than 0, and again, we need to indent because now this block is going to be within the if, which is within the try, which is within the while, and we can output something like please enter a non-negative number. And we can say continue. Now we need to exit the scope of the if, and along the line of the if, we need to break. Now we need to exit the scope of the try, and along the try alignment, we need to say except. And here we are trying to catch the value error exception. Print. We can say something like invalid input. Please enter a valid number. So now here I'm going to replace the x with the num, which is where we were trying to attempt the conversion. And we're also going to replace the x here and say num. Rerun the program, enter a number like 16, and we get the square root of 16 is 4. But what happens if we entered something like a name, like Hattie? So now it says invalid input, please enter a valid number. And let's say we enter another name like Johnny. It keeps going on and on and on. Invalid input, please enter a valid number. How it allows us to do that is because of the while loop. So it's basically saying, as long as the condition is true, then keep trying to allow the user to enter a valid number. And because Hattie and Johnny are texts and not numbers, it's basically evaluating the condition as false, and that's why it's saying try again and try again and try again. As soon as we get to a valid number, like 16, then finally it breaks out of the loop and it outputs the square root of the number. This even works for negative numbers. So suppose the user entered a negative 16. Now it tells them, please enter a non-negative number. So this is coming from this condition here. The way it works is it's saying if the number is less than 0, in this case negative 16 is less than 0, so then it's saying that that is true, it is less than 0, so please enter a non-negative number, a positive number. So if the user enters 16, now it's a positive number, so then it breaks out of the loop because we did not hit the exception, and therefore we get the output correctly.